You guys been, Daniel last week showed you some stuff, and you took a look at this review, which I renamed to errata because actually it's just more of like little odds and ends in a review. And then you guys looked at templates and serving RESTful files, or serving files and routing and RESTful applications, right? So we're really sort of like building up good stuff, and it's just going to keep going. And then all those videos are on YouTube, which, if you're watching this on YouTube, you already know that. But, here on the playlist, you could access them right through Blackboard in our course. So Daniel's videos are up there from last week. But then I also did my own take on the serving files and templates, and then whatever, all that stuff, the RESTful and routing, and before I record those, I went back through the presentation and added a few more things. So those are also up there if you need to review any of that material, both Daniel's take and my take. But today we're going to look at passing data. So like, how do we get data from the user? And that could be through form submission. They submit a form, and we could pass that either with the post or get method. And if it's the get method, it sends the data through the URL. And if it's the post method, it sends it back through the request body. And I always have to think request is coming from the client. And then we'll also look at cookies and sessions, and nothing on context yet. I don't have that in there. That's just a threshold where I've gotten to. So today we are looking at, let me just make sure I'm recording. Sometimes I'm like, did I actually hit record? It's like the sleep-deprived brain. My wife was like, yeah, because last Monday we went out to dinner with everybody. I'm like, we went out to dinner. Where did we go? It's like my short-term memory is like somewhere else. Passing data. So passing data to the server via the URL or from form submission in the body. So the URL query string and form request body. So when somebody submits a form, get method will pass it through the URL, and using the post method will pass it through the request body. And I remember that because get's 3 letters, and URL is 3 letters, and post is 4 letters, and form is 4 letters. So let's take a look at the URL query string. So here we have a URL query string. It's got a question mark, and then I have some variable, and then the value that it's set to. And so over here, when somebody comes to this URL, right, I could pull off this query string, anything after the question mark, and I could use it. And so I have HP listen and serve, listening on port 9000. What does the nil mean? It's using what? When you see the nil, it's using the default serve mux, right? So when you pass nil in there, it uses default serve mux. And if you go and you look at the documentation on that, right, what is default serve mux, right? Like, okay, well, that's a cool thing to say. It sounds totally self-explanatory, right? But if you look at what default serve mux is, we have right here under variables inside the Godoc net HTTP package, under variables we have default serve mux. And default serve mux is just a variable that gives us a new serve mux. So when that runs, what's a new serve mux? A new serve mux is allocates and returns a new serve mux. Well, what's a serve mux? And then a serve mux is an HTTP request mux multiplexer, right? And so it matches the URL. So it gives us a serve mux. And then when we get the serve mux, we have handle func, handler, serve HTTP, right? And so we've got those different methods attached to it. And you could take a look at what the serve mux is. Let's see here, type serve mux, and it gives us you could go through and start looking at how it works and everything like that. But anyhow, that's what that does. It gives us the default serve mux when you just put in nil right there. And so then here we have HTTP handle func. And so we need a handler func, and this is the handler func signature. And that's gonna, anything that comes into the server is going to handle it. And so here we say key is equal to q. So we're just setting that equal to a string, and it's q. And then we're saying value request, and so request is our HTTP request. So this is coming in from the client. Request URL query get key. Right, so we're saying get whatever. If there's a query, get me the Q, and what is that value equal to? And then we write back response, and then to the response, we're writing back this, do my search dog, right? And so we wrote that back. Kind of cool, just working with URL, getting data from the URL. And so there's two ways to get things from the request. And so this is one way right here. In a second, we're going to see the other way. The downside to query strings, and jump in if you have any more you want to add to this, we'll add to it. There's limited amounts of data can be passed through the query string. It's easily accessible to the user, right? So the user can change it. And believe it or not, back in the day, people used to build like client ID 13.9 through the URL or whatever, and then you could just change it to 14.2 and see what that client's information looked like. I miss those days. And it's messy URLs. Anybody have anything they want to add to? All right. And then request body, right? Form submission. So if we look at like what's going on here, right? So we're a net HTTP package, and we're looking at this, which is a receiver, and it's of type pointer, right? It's a pointer receiver, and it's pointer to a request. And we know that when we have this right here, we have a pointer to a request. And so this is a method that is attached to the request, and it's form value. And the method takes this as an argument, a key, and then it returns a string, right? And post and put body parameters take precedence over URL query strings. So you could use this for post, put, and URL query strings. So let's see what that looks like. And so here is the change. Like before I had that entire thing, which looked like this, right? Request, URL, query, get, key. And that only worked on the URL. And this right here will work on the data coming from the form or from the URL. And then also there's a precedence, right? So post and put take precedence over the URL, right? So if you had something conflicting, there would be precedence. And you can see that here. So I submit through this form, doggy, 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 and I'm able to get that back. And then I submit kitty, 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 and I'm able to get that back. And then I submit kitty, 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 and woof, 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 and I get woof, woof, woof. So the form took precedence. And so same thing, listen and serve, handling that, looking for a certain value, Q. In my form, I'm submitting something with the value Q, but also in the URL, I submitted something with the value Q. And here the form method is post, which means that this is going to be attached to the request body, the request header, right? That's going to be attached to the request header. Am I saying that right? Is it the header? Is that part of the header? Is that where they pass that in the header?
Yeah.
It's the body. It's the body. All right, yeah, it's the body. So excuse me, I'm misspeaking there. And then this format println value val is what prints it out to standard out the terminal. Cool. So here inside Chrome and Developer Tools, right? And you could get there by clicking this little icon right there, and then going into whatever Developer Tools. There's some other option you got to choose, and then you go into Developer Tools. You can see here under Network, when you request something, you'll see the page, but then if you click on that page, you'll get all this stuff, and you can see form data, and then the query doggy, doggy, doggy down there is what is getting passed back through the post. And I'm also just kind of looking here at this other stuff to see, because we're going to see about cookies in a second. You don't see any cookies in here right now because we're not setting any or getting any, retrieving any. So here's post versus get, and post goes through like the form body, and get goes through the URL. And so here we could see that listen and serve handle func, right, and a form, post, and text name is pretty much the same thing, but then at the end I'm appending val. I'm not sure if I did that in the last one. I didn't. So after my form is rendered, I'm also rendering in the value beneath the form, and I'm using post. And so when I submit here, right, I get my value right there. And if we were to see this, we would see it like that, right? If we looked in here, it's going to be in the body. And then here it is with get, and so I'm using get, big red arrow, get, and when I post that, I get it right here in the URL. How many people have not learned a single thing yet? Okay. How many people have learned something? All right, cool. All right, so the next one is what's going on with this one? Oh, it's just showing a checkbox, right? So, and this is with post. and submit, and then the value that comes back is on. So that's just showing a checkbox. So how do we do file upload, form submission? Ooh, cool. I feel like I'm doing something with computers when I start seeing a lot of stuff like that. So listen and serve 9000, handle func. We're looking for a queue. Ooh, we have a form, and it's of type post. We've added inc type. So I guess that stands for enclosure type.
Encoding.
Encoding. Encoding type. That's encoding type. And it's multi-part form data, so you need to add that when you upload files. And do you have anything more to say about that?
No.
Okay. You need to add that when you upload files. And then instead of using this deal here, form value, I am now using form file, right? And so form file is going to allow me to receive a file, and when I receive that, it's going to give me a file, a header, and an error. And so I don't know if I pulled up form file. I did right here, form file. And again, it's a method attached to a value receiver, a pointer receiver, which is of type pointer to HTTP request. I'm just trying to get the diction correct, the way you say that in Golang speak, right? Because Go has a language all itself to describe the language, right? But here's the pointer receiver, and it's attached to the HTTP pointer request. And that means this is a method, and so we have this method form file, and we give it a key, and then it returns these different things right here. But multi-part file, if I click on that, right, it takes me to my multi-part and then file. And basically this is a read-only file, so it's an interface, and it implements these different interfaces right here. So it's an interface defined by interfaces. And so it's a reader, read at, seeker, closer. There's no writer, right? We're not writing this file, we're just reading it. And so that's it's just kind of learning how do we read Go's documentation. So we get the file, we get the header, we get the error, and then we can print line the file, header, and error. And so down here, go run main.go, and nil request content type isn't multi-part form data, and then just kind of a lot of interesting stuff. And the one thing that Caleb pointed out was this application octet stream. You could use that to force a download, right? Like, so I think maybe you'd set that to encoding type right here, and then your browser, when it sees something like that, thinks, oh, I just need to download this file.
That's the content type.
Oh, the content type.
Yeah,
right there.
If a page has a content type of application octet stream, that basically means unknown, so the web browser will just by default go to default to download.
So that's how you could use that. But octet because 8, right? So these are bytes. Would that be right? Would that be the correct interpretation?
I think so.
Slice of bytes right there. I uploaded main.go, so that's going to be a text file, not an image file or anything like that. And so there we have that. Anybody need a moment to reflect on that, or is that all square?
So I would believe that the application is octet stream here because the web browser doesn't know what a .go file is.
Yeah.
So it's just declaring it unknown. Or if you were trying to upload an image, it would probably give you the actual image type.
Cool. Just kind of checking it out. So we print file header error. I'm just trying to figure out which is which here. Like, where's my file start? Where's my header start? Where's my error? I guess
I bet you the file is the memory address.
Error is nil. That's a file, and then this is all the header. Kind of interesting to think about. Anyhow. All right, basically read-only file. Did you want to see it more? Just stop me if I advance too fast. Welcome. We're glad you're here. Thanks. So what's going on here is listen and serve, port, default serve mux at this place, and then form file key, and then IUtil read all file. So we're reading the file since what we have is a file, and we're getting a byte slice, and then printing the file. And we have to take that byte slice and do conversion and convert that to a string. And then we're setting the header to text HTML. And then here we've got where we can upload the file. And Am I writing the file? That doesn't make sense. I should write the file. Let's see how this happens. So choose the file, main.go, and then it gives me that. Okay, so where am I writing at the terminal?
The format
Response,
print line. Format print line.
Format print line, there we go. Okay, thank you very much. Format print line, writing it to the file to standard out right there.
Yeah.
So there it uploaded the file, and then this is where you receive that upload, and then I get my file, and since that's a file, I could use IOUtil read all. Why can I use IOUtil read all for a file? I know that was a big ramble. I just rambled right there. Why could I use? Why does IOUtil read all read a file? What are the mechanics behind that? Yeah, so that's exactly like, we want to take a look at like the docs, and we'll see things about the reader. Why am I spacing on that? Because I didn't get any sleep. The reader interface, read-write interface, something like that. So go doc.org and IO, and then IOUtil, and then we have read all. And IOUtil, that's what I'm looking for. It takes an IO reader, right? And then returns a slice of bytes and an error. Okay, cool. And then I know before that I had a file here, because if I request form file, so let's go to godoc.org and then net http, and then we have our request right here, and we were using which one, form file or form value? This one, right? Form file, and then it gives us a file, and then a file, I'm like totally zoomed in, so I'm going to the wrong place. A file interface implements the IO reader interface, right? So since this implements the IO reader, we could use that right there, IO reader.
Another alternate to reading it all into memory and then dumping it out to format print line, you could just use, IO copy? And copy it from the file, which is a
That's
reader
great.
directly.
So
OS standard out.
Oh yeah, thank you. OS standard out, is that? Do I need to add that? No, it's just OS, right?
Yeah, standard out is a variable or a constant. I don't remember which.
Copy.
So copy is part of IO, and standard out is part of OS.
IO copy. Yeah, so IO copy takes a reader and writes to a writer. So you could use IO copy, and then you just copy it to
OS standard out.
OS standard out. That's what you're saying.
Which is where format print line writes to.
OS find standard out. That'll take a minute to think about. You want to demonstrate that, you think? Or no, just keep going?
Whatever.
Anybody want to see that?
So he's saying you would use the copy, but as the destination you would use your standard out?
Yeah.
Instead of using print line to print?
Yes.
Let's see it.
Since
So we're looking at
print
passing
line, if you look
data.
at its code, it's just writing to the OS standard out writer anyway. You can just go to the OS standard out directly if you need to write to the console.
Well, here it is.
That's for writing to a file.
Writing to the file.
Those are all writing to a file.
I don't know where I put that file. Here it is. Dang it, where did this go? Click the wrong thing. Passing data. There we go. All right, what do we do to get it to use IO copy?
So instead of lines 19 and 22, you would instead put io.copy. So yeah, instead of those two lines, you put io.copy. And as the destination, you put os.standard out.
Standard out. There we go. And then file.
And this should theoretically be better if it's a really, really big file.
It's a long path.
So that's running the web browser or server.
Thanks. I'm waiting for it to respond. Yeah, 9,000, right?
Yeah.
Oh, we got an error.
Okay. Because we are not sending in a file at all for the first two.
Well, we should upload it.
Yeah.
Run, go, request content as a multi-part form data. Line 29. Is that right? 29?
That looks like a time.
It looks like a time.
Go back to your code. I think the problem here is that it's trying to get the web page here, but it's going through this part first.
It should work just like the other one.
So the other one was getting back an empty byte slice
I wonder if we need that.
with an error.
We need that?
Yeah, you do. No, I think you're. The problem is you need to check if the file exists.
All right. We'll play with this later and get it working.
Yeah.
Back to the pre-scripted program. So that's what we get. So review.
Good demonstration though of if you're passing data in, make sure you check if they actually sent data in, because they may have just sent nothing.
Form value, form file, URL query, get key. 3 ways to get data back. A couple of exercises. Create an HTTP application which has a page with a form that takes in first and last name and on submit displays hello, first, last. Here's the solution. And using template. And so listen and serve 9,000 default serve mux. Parse the template right here. And there's the template. Handle func. And taking form value first, form value last, and that's coming from over here. We've got a form, and then so form value first right there, and then form value last. Those are where the values are coming from, and then printing the name, F name, and L name, and type of. Printing the type of F name. Why is F name coming in as a, oh, we're converting that to slice bytes? What's the output? I wonder if I have the output. So there we go. So entering a name, and then this is what you get in that. So F name is nothing, and that's nothing when I first run it, and the type is string, and then after I run it and enter data, James, and then that, and then type of string. Kind of interesting. I converted that to slice bytes. I'm not sure why I did that. I almost want to start editing this code. So then we execute the template. First name, last name. You have anything you want to say about this file? This code sample?
Yeah, no.
It's kind of taking a minute to look it over here.
I would say one way it could be improved, though, is to pass a person, an address to the person instead of the thing itself. Because as it is now, it's creating person in handle func, and then copying it over to template.execute. Whereas if you stick the address sign, it'll just create it here in handle func and just send the address along.
I think that's a really astute point. And one of the things that Art and Labs talked about a lot, and I'm not saying I have the right answer here, but the question that comes up for me is what is the nature of this type? And so a lot of times, like, is this a reference type already? Is the struct already a reference type? Is this already a reference type? And, you know, is it pointing to, so that's you know, when you create a value of type person, what is, and I know that's kind of confusing, but that's like, so for instance, like with the slice, it's its nature to already be a reference type because it's pointing to an underlying array. Is that the case with a struct? That's the question that arises for me. I don't have an answer off the top of my head.
No, I think it's...
Is it actually the value?
Yeah, I think it's just the value, which is the concatenation of all the internal values. So a person is the size of 2 strings, and strings are what? A length and a memory address.
Mm.
So a person is 2 lengths and 2 memory addresses.
Mm. That's cool. And then one more, create an HTTP application with a form that accepts a file and uploads it to TMP. And so that's what this looks like. Accept a file and upload it. And that was that other code we were looking at. Here's main. And right here, we're writing out a form. And this is the form we're writing out, write string. And then when that form gets submitted, right, we got listen and serve 9000. This is doing all of that right here. This is just printing out my temporary directory. So I could see that, you know, where's my temporary directory on this machine, right? So there's a variable or a function you could run to get that. And so if request method is equal to post, right, then it's going to run from here all the way down to here. So if, you know, we have post coming in as a request method, the first time when we ask for this page, what's the request method going to be? So client comes to localhost 9000 the first time they see this. What was the request method when they did that? Get, right? And so this won't run. So we just run this, which is we set, you know, a header, content type, and then we write out the form. And then when we submit, our post method is this. And so it's going to run all of that, and it's going to request form file my file and get the file and then the error. And then this one was header, file, header, error. So we're throwing away that header bit. And then we check the error and then defer and close and then create. And here we're doing file path join. So we're joining this kind of file path. And we're, what's a pending, right? That's like when you add it to the end. Prepend is
yeah.
So it's adding those together.
File path.join takes 2 parts of a path and puts them together with the appropriate middle thing, / for Windows, / for Mac and Linux. Whatever weird thing if you're running it for some weird platform.
Yeah, I think it has to be a double / for Windows because you actually have to.
Yeah, that ends up being a single byte in memory. But yeah, whatever it may be, file path.join will put join the path sections together appropriately.
Yeah, so then we get basically a destination, and we copy from the source that file that we uploaded to the destination. So we create a file on the server.
This would be a really good place to use a limit reader, as I mentioned when I was doing my first guest lecture, because otherwise they could send you a 30 gigabyte file and use up all your hard drive space. So this would be a great place to attach a limit reader around the source in order to make sure they don't upload past maximum size.
Is that in buff.io?
No, I think it's just plain IO.
IO? Because I thought GoDoc had, oh, that's scanners. Buff.io. Limit.
Yeah, I think limit reader is just an IO.
Limit reader.
Down there.
That one?
Yeah.
takes a reader and a number. Limit returns a reader that reads from R but stops in the file after n bytes. So it only reads so much. You're basically saying only go so far.
Yeah, so basically say this is the max. I don't want to go past this point.
Where would you integrate that into oops, let me go back to the code. Where would you integrate the limit reader?
I would call this, instead of source, I call it file, and then I'd say source equals new limit reader.
Oh, then you pass in the file.
Pass in the file and
Okay,
max
so
size.
Let's look at that.
That way you can still use copy, which will grab everything, but you've got your maximum. So whenever you've got something that just keeps going without regard for the size, you should probably have some sort of sanity limit attached.
So this would be a file, and then you would do
And that would be defer file
yeah,
backwards.
file there, and then you would do and that's in OS, is that IO? IO.limit, and it's going to give us the source. What's it return? It returns just a reader.
Yep.
Source colon equal IO.limit reader, and we push in the file, and then some size,
some
right?
Size, which is in bytes. So
So like
1 million would be a megabyte, I think.
3, 1, 2, 3.
Yeah, I think that's a megabyte.
Yeah, that's cool. Should we try it or just leave it at that?
That's for y'all.
Huh?
That
Should
be
still
good.
work?
Yep, that should still work. So long as whatever you're trying to upload is less than a megabyte.
Yeah, stop this server.
Does it just like,
We'll check those out afterwards.
so you don't lose, so if, in this example, you'd get half the program.
Yeah, if the file was over a megabyte in size, as soon as it hits a megabyte, it would stop as if that was the end of the file.
Well, we could play with that, right? Because we have some files, and we'll just adjust the size. So let's look at a file here. Anybody interested? Are you interested? A little bit? Yeah, why not? Yeah. Moving at the speed of 3 hours.
Does this include checking if the file name is something valid that won't hurt your system so far? Is that
Um,
we didn't put in yet?
Yeah, no, that wasn't put. He's not actually, when he's saving it, he's just using a hard-coded file name, so you don't have to worry about that.
So 855 bytes, right? So
Yeah.
if we ask for 400 bytes, should just give us part of the file.
Yeah.
Let's try that. 400 and 48, 08, 04, go run main, and localhost 9000, cool. And 04, main, open, submit, and then we should see
Off in the tempter.
in tempter. Oh no, I put it all the way in tempter. That sucks. Let's change this. Do it again.
Don't need
Get
to
rid
front
of
slash
that.
the join deals with that.
Really, I think you do. I was playing with this last night.
You have
And
to
restart
restart
it.
the server.
Go run main. Import not used format. Go run main. And that's gonna resubmit if I do that. Submit. And it should be right there. There it is. And it only gave us part of the file. That's awesome. Yeah. I love it when it works.
I love it when documentation makes sense.
Yeah.
It was actually fairly clear.
Yeah. Yeah, that's cool.
So yeah, when accepting a file from a user, it's if you're going to do something with unlimited reading like read all or copy, you probably want to use limit reader and restrict it to whatever a decent max size, like a gigabyte or something.
IO limit reader. Right, that's what we just looked at. IO limit reader. Make sure I spelled all that right.
Just a gigabyte is a understandable size for
It's a sane upper limit for a generic whatever upload. For if you know kind of what type of file it would be, like code, you can stick a lower limit. Like code's not going to be over a megabyte usually.
Cool. let me bring that down. All right, so that's it for passing data, and on an anticlimactic note.